All right, so we got our groove on with Monopoly last time. Why don't we take a quick look at that exercise that I gave you on the back side of the one. We did the one exercise with the babe spats and came to some solutions there, but just to kind of get our juices flowing, let's look at Monopoly. I don't know how much we'll work this problem out. So we got a demand curve Q equals 12.5 minus 0.25p. What is the marginal revenue curve? And calculate the marginal revenue when Q equals 6 and Q equals 7. Was it just on one page? Did I not pass that out? No. Because I got this one. So we just worked that out on the overhead, are you guys sure? Well, I guess if you're all saying that, you're probably correct. Huh, because I got these handouts, I thought I did, well maybe it's still in here. So we just worked that out on the overhead, huh? Okay. Well, this one's so, all right. You guys are probably correct. So let's work this one out. Just on the board. This one's so small. So if we have a monopoly situation and the demand curve, which makes it the market demand curve, looks like this, what did we learn about marginal revenue? What was the little trick that we had for marginal revenue? Twice as steep as the slope, and what else? That's one part of it. There's kind of two parts that starts at the same spot, yeah, for the vertical intercept. So do we just double this? Yes. Careful. Careful. Curtis has the right answer, even though he's being silent, but I see his head moving the right direction. What way was your head moving, Curtis? Got to go to the inverse demand curve. So with our graphing goggles on, we're looking at this demand curve to get that double the slope and the vertical intercept business going. So that's not what the demand curve shows. Because in this space we've got P on the vertical axis, Q, so we're looking for the inverse demand curve. So first step is to solve that for the inverse demand curve. So why don't you go ahead and do that. So what do we get? What's the new intercept? 50. All right, 1/4, flip it over, 4 times 12.5 is 50 minus 4Q. Okay, so there's our inverse demand curve. Now we can plot that up. We've got the simple slope-intercept form. What are we? Rising and running, so down 4, down to 46, over 1, da-da-da. Something that looks like that. All right, and then for marginal revenue, the graph we came to know and love in principles class. Bisect this kind of for graphical purposes, tells you it's twice as steep. It can go negative. We didn't talk about that quite as much maybe last time, but the revenue generated by an additional unit can be less. What's going on when that happens? If marginal revenue is less than 0, No, not necessarily incurring a loss. What's that? That's what's always going on. So with the demand curve, in order to sell more units, we're dropping price. So nothing different there. That's the law of demand. But marginal revenue can be less than 0. No marginal cost involved.
So your first one is 6, say your next one's 9, say the one after that is 8.
I like that you're trying to apply some numbers, but we can stick even a little more abstract, might even be easier. So what was the deal? The revenue generated by an additional unit is negative. So total revenue is falling, right? Total revenue is falling when I continue to produce more units.
Isn't there something like the marginal revenue kept going to there was like a, but it like kept going to like a certain point.
There was some certain points, yes.
Yeah.
You're onto something. Something in your memory banks is jogging, right?
Are fixed costs increasing?
No costs. Don't worry about costs. All on the revenue side.
Well, like, I'm trying to think of when I did that utility project with the chicken nuggets because the utility went really negative even though the numbers were still.
There's some similar attributes of the function, but we don't want to even think about utility in this case.
Does it have to do with price distribution?
No.
Paying utility.
It does have to do with lowering your price for each additional unit that you want to sell. Elasticity. Now let's start thinking about elasticities. What's going on if marginal revenue is negative? So remember, if we start to attach numbers, all it's saying is that the revenue generated by the 76th unit is actually negative. It's drawing away from revenue. And it had something to do with being a single price monopoly, only one price is allowed, and it has something to do with elasticity. We're on to something.
Your total revenue is 0. That's what elasticity is equal to 1.
Okay, good. You're starting to piece some things together.
When your elasticity is
Yeah, what?
more elastic.
More elastic?
Yes. No.
Okay, everybody agree with that?
Wait. It's like 5 chapters.
So here's where the revenue generated here, which corresponds to this point. What's going on with elasticity right about there on this demand curve, the way I have it drawn? It's what, John? Less, more, in, out, highly, lowly. Talk to me in terms of elasticity.
I will say elastic.
Inelastic, good. Which means it's what relative to 1? What is the elasticity relative to the number 1? Less than 1. Okay? So this is the picture you should have burned into your brains. All good intermediate econ students should have this picture memorized, especially going into this chapter and chapter 10 when we get into advanced pricing strategies. We are going to go back to using elasticities when we figure out the optimal price for that case of beer, whether it's Keystone or whether it's Michelob and whether it's bundled with a bottle of Maker's Mark or something. We're going to start getting into sophisticated pricing strategies where you need to really understand those basics of elasticity. So, ordinary downward sloping linear demand curve, marginal revenue cuts in half, twice as steep, blah, blah, blah. The revenue generated by an additional unit is 0 when total revenue is maxed out. Where the demand curve comes into here, we've got a total revenue function that is a hump. Eventually, to sell this many units, we have to cut our price to 0. And how much revenue are we going to have when we give it away for free? Zippo. That's what this endpoint is, right? So we can't ever forget that our ultimate goal of the firm is to maximize profit. You guys immediately started thinking about costs, which there's a whole bunch of fun stuff to talk about on the cost side, which we spent a lot of time in chapter, what was it, 8 or 7? Somewhere in there, We're strictly isolating revenue ideas here, and revenue is price times quantity. The law of demand tells us that in order to sell more product, we got to drop our price. So this one's always going down in order to sell more units. This one is actually always going up. That's what the law of demand. You know, like chapter 1, econ, drop price, quantity goes up. Now, the thing that most people don't think about is the elasticity part. So that's something new that economists bring to the table with the elasticity. And we're saying, oh, wait a second, sometimes the quantity effect is big. You drop your price a little bit and people just flood to your doors and you sell a whole bunch. But at other times, you drop your price and you don't have that big of a quantity effect. So the magnitudes of these arrows are what, in part, what's important about elasticity. The elasticity of demand is what's on top, what's on bottom. Top is quantity demanded. Bottom is price. So it's the relative magnitude of the percentage changes that ultimately gives us the elasticity of demand. So from this picture, we've got it all in kind of a nice little nutshell. That is why I emphasize you should have this memorized for the next test. Revenue is maximized because we're measuring total revenue here, quantity here. When marginal revenue is 0, the elasticity of demand is unitary. Over this range of the demand curve, revenues would fall with a decrease in price. A lot of businesses fall into this trap where they think, oh, we need to cut our price, our competition's stiff, cut our price, cut our price, cut our price. Well, eventually you reach this point where cutting your price actually causes a decrease in your revenues. And so the answer might have been not to cut your price, but maybe to increase your marketing. Instead of cutting costs, where the easy thing to cut is those expensive advertisements that you're doing. Maybe those types of advertisements aren't working, but you might need to try some other, and so you might need to try some other strategy, but you need to elevate the desire of your product maybe, because if you're in this range of the demand curve, you should actually be raising your price. And over this range, the elastic portion of the demand curve, the elasticity of demand is greater than 1. So you guys have seen me do this a number of different times. This will carry you in a number of different ways. That's why I like to bring it up. Again, here, how this thing works as a tool is if we're cutting price moving from A to B along the linear demand curve, that corresponds directly with 2 points, A prime and B prime, on the revenue function, illustrating that a cut in price when demand is inelastic leads to a fall in revenues. However, if you're up here where demand is elastic, moving from point C to B, or C to D, a cut in price, even if it's the same in magnitude that you were doing before, because demand is elastic, a cut in price leads to an increase in revenue. Because the quantity effect, the numerator up here, the quantity effect is bigger than the price effect, causing an overall increase in total revenue, which is price times quantity. Did I see a hand up?
Yeah, I may be jumping the gun, right? But I just have a question. Obviously, this, like the graph on top doesn't apply in competitions that say monopolistic competition or another form of market.
Yes, you have to have some market power to even think about changing
Yeah.
price. Otherwise, you're a price taker. Good point.
But what if the equilibrium at one point is at point A, B? Would that firm eventually try and play a game and be like, hey, let's raise the prices so we all get total?
Depends on the market structure. So that's where we start getting into different assumptions, like an oligopoly where there's a few firms and we might be able to do some strategic behavior. If it's monopolistic competition, you've got a little bit of wiggle room, but the demand curve is relatively elastic. So it'd be pretty flat. We'll get to those shortly too. But have this, regardless, anytime there's a downward sloping demand curve, this is the situation the firm faces in some capacity. Okay, so back to our problem here. Calculate the marginal revenue when the quantity is 6. So marginal revenue is the same starting place, 50. The vertical intercept's the same. And then we're going to double that slope to 8. And at a quantity of 6, we simply plug into 6. 6 times 8 is 48. 50 minus 48 is 2. So marginal revenue equals 2. And if we look at the next unit at 7, 7 times 8 is 56. And marginal revenue is equal to a negative 6. All just highlighting what's going on, because you're right, it doesn't seem to make sense. That's why you got to fall back on this analysis. Why does an extra unit cause revenues to fall if I'm selling it for a positive price? And the reason is I have to drop the price for all the previous units. And so even though you're still selling this unit for whatever this price is, if this is $10 and this is $8, you're still selling it for a positive price, but the revenues are falling because you also had to drop the price for all of these other previous units. Okay, any further questions or comments on that? This is a big backbone to a lot of where we're going, so ask now. Not to say that you won't be able to ask later, but ask now. I don't have it here to hand out, and all it is what we just wrote. It is in your book, too. This is it, this little guy right here. It says, suppose the demand curve is this, and what is the marginal revenue that corresponds to this, and calculate the marginal revenue at this. So that's really all it is. All of this was bonus material. This is the stuff you really need to know. It was kind of a lead into that. What's that? Oh, and then rework them. Okay. Well, that's in your book, too. So you can go back into there. I'll be happy to make you a copy if you want it. All right. Well, let's try another one. You'll get some more practice here, too. All right. Let's do this one. So we got the Power Tires Company. The Power Tires Company has market power and faces that demand curve. And then we're going to bring marginal cost into it as well. All right. Firm's marginal cost is 30 plus 3Q. What is the firm's profit maximizing output and price? Okay, so first of all, profit maximizing output, part A, A1, if we want to call it that. How do we find it? How do we find it? Profit maximizing output. Marginal revenue equals marginal cost. So find the quantity where the revenue generated by the last unit is equal to cost. All we're given is this demand curve that's shown graphically, and then you've got the marginal cost curve. Erase some of this stuff. That wasn't us. First person that generates a marginal revenue function, why don't you let me know what it is? I'll write it on the board and see if we all agree. Whether you're right or wrong doesn't really matter. Negative 6q plus 300. Do I see any nodding heads? Does that look good? Yeah? Alright, so here's the picture that's in your problem. $300 down to 100. Somebody come up with a quantity yet? Set marginal revenue equal to marginal cost. And solve for quantity. Anybody got a quantity yet? 30. So quantity equals 30. Price? 210, how'd you get it? Plug this into the inverse demand curve, right? So our inverse demand curve in this case is 300 minus down 3 over 1, 3q, shove in the 30 into the q, 30 times 3 is 90, price equals 210. Alright, so sub into inverse demand. Okay, so now we have a shift in demand in part B. If the firm's demand changes to 240 minus 2q, while its marginal cost remains the same, is the firm's profit maximizing level of output and price. What is it? So marginal revenue for this new function would be 4q, double the slope. Marginal cost was the same, which I hadn't written down before. So it's 30 plus 3q. Quantity still 30. Good. So we're doing the same exercise. Set marginal cost equal to marginal revenue and solve for Q. Quantity equals 30. Sub that back into your new demand function. So sub equation 1 into the new inverse demand. And what do you get for price? How much? 180. So here's our inverse demand curve. 30 times 2 is 60. Price equals 180. All right. Well, that's kind of weird. What does that say about the supply curve? What was the supply curve equal to in perfect competition? What was the supply curve equal to a purpose?
Marginal cost.
Marginal cost, right? As long as it was above average variable cost, supply and marginal cost were one and the same. Is that what's going on here? Is the supply curve the marginal cost curve? So if we're to graph this marginal cost curve, what does it do? It comes in here at 30 somewhere, wherever that is. And then it goes up. Let's see, we're at a quantity of 30. Try to draw some sort of graph that looks relatively the same. So let's go something like this. All right. So we had a slope of marginal cost as a function of Q of 3. We had the 30, right? So this is roughly a graph of what we're looking for. And so is the supply curve and the marginal cost curve one and the same here? What is a supply curve? By definition, kind of law of supply. Well, let's go ahead and start off with the law of supply. What does the law of supply say? Law of supply. Price goes up. Quantity supplied goes up. We want to be a little bit careful with quantity now. Quantity supplied instead of saying the supply curve, kind of old school principles class. So price and quantity, a positive relationship between those two variables. Of course, holding all other things constant, ceteris paribus. So there's our law of supply. Well, that kind of looks like this. Price goes up, quantity goes up. But what's going on with this problem? Yeah, so they're changing the demand curve, and so did price go up or down? Price went down, quantity went nowhere. So price went down, quantity went nowhere. Right, right. That's what they kind of rigged it. Don't get me wrong. I mean, they did this intentionally, but it's there to just say, well, as demand changes, we might not get the same reliable relationship that we had here with marginal cost. So in this case, we had the intercept dropping down to 240, and I'm just kind of eyeballing things here, but what was the slope? -2, so a little bit flatter, right? And so if you give me a little bit of liberty here, let's say this is, I don't know, going like this, and then this is going like this, right? Something like that was going on. And you could draw it more carefully with some graph paper, but at the end of the day, marginal revenue equaled marginal cost here. We go up, and we got a price of 180. So if we were to try to map this thing out, we were here at was it 240? No, 210. So we were here at 210, and that's our supply curve. So does that mean supply is horizontal? Or I mean vertical? Well, we could maybe do that. But had we shifted this way, let me just do this a little bit. Let's just take this slope and make it 1 or something. Let's make it a little bit steeper. Now, if I do that, what happens to quantity? It falls. So that could screw it up. If I take this and move it a little bit up, then quantity goes up and price still goes down. Everybody tracking with me on that? This might take a golf club now. So imagine just goofing around with this one. We got this answer here. So all I'm saying is if we would drop this, then the marginal revenue curve would drop down. The intersection point would be there. We'd be at some price there. But if I take it now this way and make it a little flatter, marginal revenue is going to kick over here somewhere, and the price is still going to be less than where we were before. Does that sound like a systematic relationship between price and quantity? Here, price is still going down in all these cases, but quantity may have gone up or down. There is no supply curve in a monopoly situation. The monopoly is a price maker. The supply curve is not the marginal cost curve. There simply is no supply curve. price is a choice variable depending on the circumstances. So we don't have a supply curve in the perfectly, or in a true monopoly situation. Price is a choice variable, and there's no connection to the marginal cost curve, or not in the same way that we had before in terms of supply. So the lesson that we get out of this is, let's just say there is no supply curve in monopoly. There is no systematic relation between price and quantity supplied. It is demand dependent. Price is a choice variable. So comparing this back to perfect competition, or what we saw in a competitive environment, marginal cost does not equal supply. It's all demand dependent. Okay, questions on that part? Okay, so I guess the last part is what we did here. So try to draw this graph if you can a little bit. You'll be able to look back in your textbooks, but that was part C, was drawing that graph. But at least have the concept down of how we can tweak demand and get different answers. All right. Any last questions on that one? Okay, back to the barbecue joint we had before. BB's barbecue. If you flip over your page. Okay, so we had an inverse demand curve at Babe. Well, this is Babe's Bats. I was thinking barbecue for the BB, but this is a bat company apparently. So we've got an inverse demand curve for the bat company. This is like I said, a continuation of the first example we went through. And we had that for the inverse demand curve. And now let's add a marginal cost curve of 5Q. Well, we're not now adding, that was there before. So this question is to calculate the deadweight loss from market power at the profit maximizing output. So calculate deadweight loss at the profit max quantity. All right, so before we dig into this one too much, what was the concept of deadweight loss with the monopoly? What was the concept of deadweight loss?
It's almost like when there's a tax, it's just that it's revenue.
All right, so let's think. I'm glad you brought that up. Let's think about the tax situation. So we have a supply and demand curve. The market's kicking out some equilibrium price and quantity. And then we impose a tax. The consumer's price goes up, the producer's price falls, and we had this deadweight loss area. So why was that deadweight loss? Kind of what is a deadweight loss, I guess, in a sense? What are we tying this back to? Yeah, it is in this case, not an overproduction, but underproduction. So it is tied to that. Society's welfare. What was going on with society's welfare here? Talk to me about the supply curve and the demand curve and what they mean to society. How do we know that?
Because the equilibrium quantity demanded is for the quantity.
Correct. And so what did we call this quantity? From society's standpoint, it had a little AE associated with it, hint, hint. Allocative efficiency. What did we need for a quantity to be allocatively efficient? What was true about the benefits and costs of marginal benefit equals marginal cost? So the benefit of the last unit produced is equal to the cost of the last unit. I don't see a marginal benefit curve up here. What is reflecting the marginal benefits? The demand. The demand curve is the marginal benefit curve. I don't see a marginal cost curve up here. What's the marginal cost? Supply. Now, that's where we start to depart from the monopoly situation. I just got done explaining that there is no supply curve, but there was a marginal cost curve, right? That was a legitimate marginal cost curve. It was the cost associated with another unit of production. And did we have a demand curve? Yes, we had a demand curve. So, from this picture, we can pick out the allocatively efficient quantity. And I'm going back to our old picture here, but this demand curve or this demand curve, both of these are marginal benefit curves. That's the cost associated with an additional unit. So marginal benefit equals marginal cost here under that situation or here. Both of these quantities are greater than what the monopolist is cranking out, which was only 30 units. So you're correct in thinking about the tax and that there's an underproduction of the good, therefore creating a deadweight loss. It's going to look very similar to this picture. Here's the quantity that's being produced. If I pick on the green marginal revenue and demand curve here, that just helps anchor the problem. The 32nd unit has benefits of this amount and costs this amount. From society's standpoint, would we like to see the 32nd unit produced? Yes, we would. And the 33rd and the 34th. And so we get that similar triangular region here with monopoly. And that is the deadweight loss from monopoly. Now let's apply it to this problem. So thumb back to your picture and probably redraw what we did last time on this Babe's Bats. So we have a vertical intercept at 25, a slope of negative 2.5. We don't have to draw it perfectly to scale. We have a downward sloping marginal revenue curve. Sometimes we shortcut. We don't have to draw it below because we kind of know what's going on now. We have a marginal cost curve with a vertical intercept of 0. And we did kind of cover this before. So that thing's kicking up looking like this, maybe. So now we're starting to see the gaps filled in. What did we calculate last time where marginal revenue equaled marginal cost? The monopolist was producing a quantity of, which was that? Everybody got their old one? Sam, you got something down there? pull out your old notes. So we spent quite a bit of time on this problem on the first phase of it. How much, Chelsea? 2.5, correct. So find out where you got that in your notes. We did quite a bit on this problem. This is actually a smaller part of the problem. I just want you to make sure you know you've got this earlier. So we have a quantity of 2.5. And then what was that price once we substituted it into the inverse demand curve? 18.75. Now, what was the revenue generated by the 2.5 unit? That was kind of hard to say. At 2.5, what is the marginal revenue? Or we could substitute it into the marginal cost, which might be a little easier given this function here. What do we get? 2.5.
sorry.
How much? 12.5. So $12.50, since we're thinking of dollars here. $12.50. Now we have not calculated this point yet, so that one you need to do. We've got the inverse demand curve. Where does that equal marginal cost to find the allocatively efficient quantity? So, to find QAE, set marginal benefit, which equals demand, the inverse demand curve, which I'll just write out, equals 25 minus 2.5Q, equal to 5Q, which is our marginal cost. We got marginal benefit equal to marginal cost. And so what does our quantity end up being? 3.33. 3.33. Still not done. Deadweight loss is the dollar value of loss to society. An estimate of the dollar value loss to society. So we need to go back to some geometry here. What do we get? Anybody solve it yet? $2.60. $2.60? See a couple heads. What's that? Times 1,000 if we're in thousands of units. Yep. Yeah, I think that was, they didn't restate that here, but I think you're right. It was in thousands here. Yeah, 2.59375 roughly. Yeah, would be it. So 260 is fine on that, but then changing it to the thousands means that there's $2,000, 590. So then the rounding all of a sudden makes sense. So the deadweight loss is the area of this rectangle. We have all nice straight lines, so it's that area. So however you guys calculated it, again, you should come down to 2.59375. You can break this into two right triangles, which is $2,593.75. is the producer surplus? How would you show that area? It would include the triangle below it. Yeah. So the producer surplus would be this kind of trapezoidal area. Consumers would still be enjoying some consumer surplus up here. So there's consumer surplus, producer surplus. And so the trade-off here is producers are potentially, in theory, losing something of what they could get, but they're gaining much more. So it's definitely to their benefit to act this way. It's the profit maximizing thing to do. And consumers are the ones that are losing. So that is how we go back kind of accounting for all parties' welfare, creating a deadweight loss. Okay, and that'll help us out getting into chapter 10. So that wraps up chapter 9. Let's have chapter 9 homework due this Friday. And we'll call it a day there.